Hi there, welcome back to another video from the Math Doc. This time we'll be talking about absolute values, and we'll start from the beginning. We'll define what an absolute value is and show some examples, and hopefully this will explain what you see between those two lines. Remember, the absolute value is just, we show it as something between two straight line. What is the absolute value of 5, or what is the absolute value of -5? So we'll talk about that. But let's get started first by talking about the distance between two numbers. So you may know that the absolute value is also identified as the distance of a number from 0. But let's go back and discuss what the distance between two numbers is. For instance, if we have the numbers 2 and 4, what is the distance between them? Well, some people will subtract the smaller number from the bigger. So we can say, oh, we have 4 and 2, so we have 4 minus 2 equals 2. So the distance between 4 and 2 is just 2. The other thing we can do is we can count how many on the number line, how many numbers are between, between these two numbers. So we go from 2 to 3, and then from 3 to 4, and that's exactly 2. What if we want to go from 4 to 3, and then from 3 to 2? Again, we take 2 steps. So basically we're counting steps between the two numbers, and the direction of those steps doesn't matter. Okay, so direction doesn't matter. And this is important because we're looking at the distance between the two numbers. Okay, we don't care if we're walking to the right or to the left. We just want to know how far we're going. Let's take a slightly more complicated problem. Let's say, what is the distance between 1 and -3? Okay, so if we have 1 and -3, let's do the counting first because that is simple. We count 1 step, 2 step, 3 steps, 4 steps. So counting the steps will just give us 4. Let's also count the other direction. 1 to 0, that's 1. To -1, it's 2. To -2, it's 3. And to -3, it's 4. So basically the number of steps is 4. We're looking at the distance between -3 and 1, and this is how we can write that combination. So the distance is from between -3 and 1 is just 4 steps. Now let's try to use the subtraction method. Okay, so we take the larger number. Well, the larger number is 1, right? 1 minus, and the next number is -3. I'm going to put that in parentheses so it's obvious that we're looking at -3. When we have a double minus, what does that mean? That is just 1 plus 3, and that equals 4. So in both methods, we get the same result. Let's look at another one. Let's say we'll do this one in green just to be different, and let's look at 3 and -4. Okay, again, let's look at the steps. Let's count the steps. 1, 2, 3, 4, 5, 6, 7 steps. Okay, 7. Let's go in the other direction. 1, 2, 3, 4, 5, 6, 7. Okay, so by counting the steps between the two numbers, we get a distance of 7. Now let's use the subtraction. Okay, so we have 3 and -4. Which is the larger number? Well, clearly 3 is, because 3 is positive and -4 is negative. So we do 3 minus -4, which is equal to 3 plus 4, because we have two negatives, right? And that is just equal to 7. So we get the same result. So we've confirmed now that we can find the distance between two numbers in two different ways. We can either count the steps or we can subtract. Now, why do we have two ways of doing this? Well, sometimes counting steps is not very practical. If we're looking at the distance between the number -7 and 53, for instance, we don't really want to have to count the steps. That'll take too long. What we can do is we can use the subtraction. We can say 53, which is the larger number, minus -7, right, is equal to 53 plus 7. I'm running out of space, which is just equal to 60. So counting the steps is kind of very clear and obvious way of measuring the distance between two numbers on the number line, but subtracting the smaller from the bigger is really a more practical thing to do. So now let's look at this distance thing again. And there's something important that you have to understand about it. When we look at the distance between two numbers, so again, let's look at, say, 1 and 4 here. Okay, and let's do the easy thing and count steps. We have 1, 2, 3. The distance here is 3. We can also go backwards again and count 1, 2, 3. So the distance here is 3. You see that regardless of the direction we count, we always count a positive, okay, number. The distance between two numbers is always positive. It's always greater or equal to 0. When is it 0? Well, it's 0 when we're looking at the distance from a number and it's between a number and itself. So the distance between 5 and 5 is just 0, right? So that's when it's 0. But leaving that alone, it's always positive. So regardless of whether we're looking at positive numbers or negative numbers, the distance between them will always be positive. So if we're looking at here at -4 and -1, right? We do the same thing. We count the steps. 1, 2, 3. The distance is +3. If we go the other way, again, 1, 2, 3, and we get +3. So the distance between -4 and -1 is +3, just as the distance between +4 and 1 or +1 and 4 is +3. Okay, so it's very important to remember the distance is always positive. And so here we get to what the absolute value is. When we're looking at the absolute value, we're looking at the distance of a number or an expression, which is something we will look at later. But for now, let's focus on a number. We're looking at the distance of a number from 0. So we really should put the parentheses here. We're looking at the distance of a number or an expression from 0. So if we're looking at the absolute value of 5, okay, we'll look here, 5, and we're looking at the distance from 0, right? So the absolute value of 5, and using these two straight lines is how we identify the absolute value. That is just the distance between 0 and 5, and we can count 1, 2, 3, 4, 5, or the other way, 1, 2, 3, 4, 5. Basically, it equals +5. Now, what is the absolute value of -5? Well, that is the distance between -5 and 0. What does that equal? Well, we start here again. We go to 0. We go 1, 2, 3, 4, 5. That is +5 too. Same thing happens if we go the other direction. 1, 2, 3, 4, 5. Still 5. So the absolute value of 5 equals the absolute value of -5 equals the absolute value of 5. It's just equal to 5. Okay? the absolute value of negative 3 will be equal to the absolute value of 3, which is just, let's use now the subtraction, 3 minus 0, right? We're looking at the distance between 3 and 0, which is just 3. So this, in general, is what we do. If we have any number, say we'll call the number n, okay? If we're looking at the absolute value of n, that is equal to the absolute value of negative n, regardless of whether n itself is a negative number. And that is always a positive number, okay? And it is equal to the distance between n and 0, okay? Again, regardless of whether n is 100 or minus 73, it is always equal to the absolute value of the negative, and it is all the absolute value of it is always positive. So let's just look at some examples, okay? And we'll remember again that we're looking at the distance of a number or an expression from 0. So here we go. Let's say we have the absolute value of negative 3. Well, what is the absolute value of negative 3? It's just the distance, right, between negative 3 and 0. Let's count that out. 1, 2, 3 equals positive 3. Okay, what is the absolute value of 5 minus 2? Okay, well, what we can do is we can actually solve for this. This just equals the absolute value of 5 minus 2, which is 3. So the absolute value of 3. Again, we're looking at the distance from 3 to 0. 1, 2, 3. That's equal to 3. Let's do another one. What is the absolute value of 9 divided by 3? Okay, let's solve for 9 divided by 3. That's just 3, right? So we have the absolute value of 3, and that equals, once again, positive 3. What else can we do? Well, let's say we're going to do what is the absolute value of 1 divided by 4? Oh, well, that is already a little more complicated, right? We've only looked at real numbers. Well, remember, this is the distance of this number in here from 0. So what do we have in here? We have a quarter, right? Or we can write it out in a decimal format as 0.25. What is that? Well, it's the distance between 0.25 and 0, right? What does that equal? It's 0.25 minus 0, which is just equal to 0.25. So absolute values for fractions are just the same as absolute values for whole numbers. Basically, it's correct for any rational number, okay? Any real number or rational number. So we can do many examples, but basically, if you have another example would be, how about the absolute value of minus 3 divided by 2? Well, that equals, first we do the absolute value. That's in the first order of operation. So the absolute value of negative 3 is just 3, right? We go 1, 2, 3, as we've done before, and then divide by 2, and that is just 3/2, right, or 1.5. So basically, what the absolute value does is it looks at a number and it says, well, I'm going to take your size, but I'm not going to care if you're negative or positive. I'm just going to make you positive. So it's always positive, regardless of what it started off as. And then I'm going to do with you whatever I would do with a regular number. So whatever you start off with, I'll make you positive, and then I'll continue doing whatever I have to do within the mathematical expression. So what else can we do with these absolute values? Well, the next thing we'd like to do is kind of use it in algebra. So what does that mean? Are we going to be looking at absolute values of variables? Yep, we will. But when we have variables, we don't really know if they're positive or negative. So how do we work with this? Well, it turns out there's a trick. What we have to do is we have to ask what happens in each case. Okay, so what we can do is if we want to know what the absolute value of x is, we can say, well, we can have a case where if x is larger than 0, and we have a case where x is less than 0. If x is larger than 0, then the absolute value of x is just x, right? And if x is less than 0, well then the absolute value of x should be minus x, right? Because if x, say, is a negative number, right, then we have to turn it into a positive number. And we do that by adding a negative, right? So if x was 3, then the absolute value of x is just 3. But if x was negative 3, then the absolute value of x is plus 3. So we've added another negative to the negative. So that is how we actually work with absolute values when we are not sure what we have inside the brackets, okay? When we're not sure what we have inside the brackets, we have to ask what would happen in each of these two cases, okay? So regardless of what we have inside, we can ask ourselves what happens if it's positive and work through the problem, and what happens if it's negative and work for the problem. And then the next few slides will actually look at these types of problems. So before moving on to the next examples, let's see what this actually means in terms of what this function or what this absolute value does. So we said that if our x here is larger than 0, that means that the absolute value of x is just x. So let's draw the y-axis here, and we'll say that y equals the absolute value of x. So for x equals 1, the absolute value of x is just 1. For x equals 2, the absolute value is 2. For x equals 3, it's 3, right? Now what happens at 0? Well, the absolute value of 0 is just 0, right? It's the distance from 0 to 0. Now let's look at negative x's, right? So for x equals negative 1, the absolute value we said is just the negative of that, right? We said it's making it positive. So it is 1. It's minus 1. What is the absolute value of negative 2? It is negative 2, which is just plus 2. So we have that right here. And for negative 3, the absolute value of negative 3 is just plus 3, right? So we're up here, and this is what it looks like. So if we graph this, the absolute value of x, we get like a V shape. And that, again, is a reminder that regardless of what we have between the absolute value lines, the absolute value is always positive, okay? And that's important to remember. It's always positive. So now I guess we can go on and look at our next example, which is slightly more complicated. So let's look at this one. What we have here is the absolute value of 5 minus x equals 3, right? Now, if the absolute value was not in there, we would know what to do. We would isolate x by moving it from one side to the other of the equation, and then move 3 over, and we'd basically be left with x equals 2. But here we have the absolute value sign around the 5 minus x here. And so we can't just move x around. First, we have to get rid of the absolute value. So before we can do anything with the inside of it, we have to get rid of the absolute value. How do we do that? Well, we have to look at two cases, just like we did for the absolute value of x. We look at the case where what's inside is positive or negative. Both options are valid, but we have to look at them separately. So let's first look at the first option, which is that 5 minus x is larger than 0. Let's say larger or equal to 0. Well, in that case, if what's inside the absolute value is positive, then we know that it's actually just equal to itself, right? We don't have to change the sign in any way. So the absolute value of 5 minus x is just 5 minus x. And let's bring down the right-hand side here, and that equals 3. So now we can do our magic with the equation. Let's add x to both sides of this equation. And we have 5 minus x plus x equals 3 plus x. And these two x's cancel. And now we just have to subtract 3 from both sides in order to get to have x isolated. So we have 5 minus 3 equals 3 plus x minus 3. These two 3's on the right cancel, and we have 2 equals x. So x equals 2. And that is the answer when we also assume that 5 minus x is positive. Well, it really is, right? 5 minus x is just 3 in this case because we say x equals 2. Okay, so one result is 2 right here. Okay, now let's look at the opposite case where what's inside the absolute value is actually negative. So what happens if 5 minus x is less than 0? In that case, the absolute value of 5 minus x actually equals minus, okay, negative 5 minus x, right? Because this thing on the inside is negative. That's what we're assuming. And so if we want to look at the positive absolute value, we have to put another minus there, and the two minuses will cancel, okay? Just like we saw for the x. So now we have minus 5 minus x equals 3, right? Right there. So let's open these parentheses. We have minus 5, right? Negative 5. And then we have negative, negative x. So we have plus x, right? Two negatives give a positive, and that is equal to 3. Now, again, we're going to isolate by adding 5 to both sides. And we have negative 5 plus x plus 5 equals 3 plus 5. So these two 5's cancel, and x is equal to 8. Okay, we'll lengthen this axis here, 6, 7, 8. And so these are the two results. Our two results are x equals 5 or 8. Not 5, actually, 2, we said. Okay, and let's check this again. When we have x equals 2, 5 minus x is 3. The absolute value of 3 is just 3, and that's okay. What about 8? Well, 5 minus x minus 8 is negative 3, right? 8 is just 3, is 3 units larger than 5. So 5 minus 8 is minus 3. But what is the absolute value of minus 3? Let's look at that on the number line right here, minus 3 in red. It's 1, 2, 3, right? Because we're measuring the distance of what's inside the absolute value from 0. So the absolute value is just 3, and again, we are okay. So let's look at one final example that is actually somewhat confusing. So I feel it will be a good idea to work with this one for a bit and see where are the pitfalls with this type of problem. So this example is similar to the previous one. We have inside the absolute value 5 minus x again, but instead of writing 5 minus the absolute value of 5 minus x equals 3, I added instead 3x here. Okay, so we have x's on both the inside and the outside of the absolute value. But again, we can't just solve this by isolating x without paying attention to the absolute value. The first thing we have to do is separate the cases and make sure we're treating the absolute value with the respect it requires. So again, let's look at the case first where 5 minus x is greater or equal to 0. In that case, we know that the absolute value of 5 minus x is just equal to 5 minus x, and that should be equal to 3x, right? So now we can we can add x to both sides, right? And 5 minus x plus x equals 3x plus x. And the minus x and x cancel, and we have 5 equals 4x. And so we can divide now by 4, right? We'll divide both sides by 4, and we're left with x equals 5 quarters, where I flipped the directions just so I can write the solution in that format. So we have x equals 5 quarters, which is also equal to 1.25, right? It's 1 plus a quarter, and that's more or less there. Now, what happens if we look at the opposite conditions? What if 5 minus x is less than 0? Well, if 5 minus x is less than 0, then we have minus, right, negative 5 minus x, because we have to flip the sign in order to get the absolute value, is equal to 3x, right? Now let's open these parentheses. We have minus 5, negative negative x, so that's just plus x, equals 3x. Let's subtract x from both sides, and we get minus 5 plus x minus x equals 3x minus x. These two x's cancel, and we have minus 5 equals 2x, or let's divide by 2, both sides, and we have x equals minus 5/2. Okay, so strictly speaking, this should be a solution, right? But let's look at this again. What happens if we check whether our first condition here, that what's inside the absolute value should be less than 0? When we check back here, what we get is, if we insert this, we get 5 minus negative 5/2, right? So that's just 5 plus 5/2, which is just 7.5, right? Because 5/2 is 2.5, and we add the 5, so we get 7.5. But 7.5 is not less than 0. So this is not a solution, okay? That means that when we went in this route, we actually couldn't find a solution. So this equality here, this equation, has a solution only when what's inside the absolute value, 5 minus x, is larger or equal to 0. This option doesn't have a solution. And so we have just one solution right there at 1 and 0.25. So this is actually a really good example where we've learned a few things. First of all, what do we do when we have our variable both inside and outside the absolute value? We always have to be careful with the absolute value. The first thing we have to do is separate out the two cases of a negative content of the absolute value and a positive content. We solve for both of these, and sometimes our solution is not a real solution because we may get a solution, but it does not satisfy our original requirement that we put in order to solve this equality, this equation. So this was really our first video about absolute values. In the next video, we will look at a few simple word problems with absolute value, and then we will continue to inequalities with absolute values, which are especially interesting and actually especially realistic in terms of the problems. So I hope you enjoyed this video. Please leave comments if you have any questions about the absolute value or the examples. I'll be happy to look at specific examples. If you can, please subscribe, like, and return to the next video. Thank you and see you next time.